This is a Unit 4 test review on proportional reasoning. Number 1, Marty's used car lot has 3 Hondas, 5 Mazdas, 4 Fords, 1 BMW, and 6 Toyotas. A, what is the ratio of Toyotas to Hondas? Express the ratio in all 3 ways and write in simplest form. All right, so the 3 ways to write our ratio are as a fraction, with a colon, and with the word to. So we're going to do that all 3 ways. So first way I'm going to do is as a fraction, so I can see that it's Toyotas to Hondas, so I want to make sure I get that in the right order. So there are 6 Toyotas and 3 Hondas, so 6 over 3, but that can be simplified by 3, so I'm going to go ahead and do that, and so that would give me the fraction 2 over 1. And I can also write that with the colon, 2 to 1, and then I can also write that with the word 2 to 1. Okay? What is the ratio of Fords to total cars? Express the ratio in all 3 ways and write in simplest form. So again, I want to make sure I get this in the right order. So I have Fords, there are 4 Fords to the total number of cars, so I need to add these up. So 3 plus 5 is 8, 8 plus 4 is 12, 12 plus 1 is 13, 13 plus 6 is 19. So this is going to be 4 out of 19, and I do include the Fords in that because it's the total amount of cars. All right, so this cannot be simplified, so I'm just going to write it the other 2 ways with a colon and then with the word 2. Okay? All right, number 2, Lori can read 85 pages in 17 minutes. Kathy can type 64 pages in 12 minutes. Use unit rates to determine if each pair of rates is equivalent. All right, so I am going to, if I need to find a unit rate, I'm going to set that up as a fraction, but then I know as a unit rate, an UNO rate has to have a 1. So I'm going to divide to find the unit rate. So I'm going to divide 17, top and bottom out, into 85. 17 will go into 85 5 times. Yeah, 5 times. All right, so the unit rate is actually 5 to 1. And then if I find the unit rate for Kathy, that would be 64 over 12. Again, I'm going to divide 12 into 64, so that would be 12 go into 64 5 times, which is 60. And when I subtract, I get 4. So I add a decimal and a 0, bring that down. That's going to be about 3 times. And that's going to keep repeating, so 5.3. So if I write this again as a unit rate, that's going to be 5.3, repeating to 1. This one is 5 pages to 1 minute. Per minute, I could do 5 pages per minute with a slash as well. This is going to be 5.3 repeating pages per minute, like that, or I could do it this way, over minutes like that. Okay, and then the question is it an equivalent rate? And so since this one is 5 and this is 5.3 repeating, then I would say no, these are not equivalent. They have different unit rates. Not equivalent. Okay, so again, unit rates, and you set up as a fraction, divide it, and then make sure your denominator is 1. So unit rate means UNO rate. Don't forget that little hint. All right, Mrs. Smith wants to buy drinks for a party. She compared prices at 4 different stores. Which store sells drinks for the lowest price per can? All right, so I'm going to be finding the unit price, so that would be the cost for just 1 can, and then I can compare the unit prices for all 4 stores. So with unit price, the price is always on top. Again, I'm setting that up as a fraction, and then I'm dividing. So I have $3.66 over 6, and then if I go ahead and divide 6 into $3.66, bring out my decimal, 6 will go into 36 6 times. I'm going to subtract that and bring down the 6. 6 will go into 6 1 time. So that leaves 0.61, so that means the cost of 1 can is 61 cents. All right, if I do the same thing for Walmart, I'm doing $7 for 12 cans. So if I go ahead and divide 12 into $7, bring out my decimal, 12 will go into 7 5 times. I'm going to subtract 60, that gives me 10, bring down another 0. 12 will go into 100. 8 times, yeah, 96. I can subtract that and get 4. If I brought down another 0, 12 will go into 43 times. I'm going to stop with 3 decimal places. So that would be 0.583, and then I would round that to 58 cents basically per can. All right, so then if I look at Walgreens, it's going to be the price on top, so $6 over 10 cans, and I'm going to divide 10 into $6. Bring up my decimal. 10 will go into 60 6 times. Bring down my 0. It'll go 0 times. All right, so then the Walgreens price is 60 cents per can. And then the last one is Randall's. So if that is $4.64 for 8 cans, and I divide 8 into $4.64, 8 will go, bring up my decimal, 8 will go into 46 5 times, subtract 40. That gives me 6. If I bring down the 4, 8 will go into 64 8 times. All right, and then I'm done there. So 58 cents for Randall's for 1 can. And then if I compare the unit prices, I have 61 cents. This rounds to 58 cents, 58.3. 60 cents and 58. So this one rounds to the same thing as Randall's, but this is like 0.580. It is actually a little cheaper, so Randall's is going to have the best unit price. All right, and then Kevin, number 4, drove from El Paso to San Antonio. He can drive 360 miles in 3 hours. Which of the following best represents Kevin's miles per minute? All right, so I'm going to start with 3 per minute. That's a unit rate also. So I want to go 360 miles over 3 hours. And then if I read correctly, this is per minute. So I have a couple choices. I can go ahead and change hours into minutes, or I can go ahead and find the miles per hour and then change it then into minutes. So you kind of have 2 choices. I'm going to show you both how to do it. So if I go ahead and change hours into minutes, I know that there are 3 hours, and I know that there are 60 minutes in an hour. So if I multiply it 60 times 3, I'm going to get 180. So I can go ahead and change this to 360 miles per 180 minutes, and then find the miles per minute. So if I divide 180 into 360, it'll go twice. And I'm done. All right, so then that would end up being 2 miles per minute. Okay, which tells me D is the correct answer, miles per minute. But say maybe I didn't notice that right at first, and I just went ahead and divided 360 divided by 3. So if I did that, because the division's a little easier this way, I would get 1, bring down the 6, that would be 2, bring down the 0, I get 120. But that's 120 miles per hour for 1 hour. So if I want to go from this ratio into minutes, then I could change this one into 120 miles. And I know that there are 60 minutes in an hour, so I could just change it here and then divide again. So 60 would go into 120 2 times, and then I'd be done. So I'd still end up with 2 miles per minute. But I just have a couple ways to get there. So just be sure you see that it's per minute and not per hour, because a lot of times we do it per hour. All right, number 5 says a bookstore receives a shipment of 245 books in 7 boxes. At this rate, how many books will it receive in a shipment of 19 boxes? This statement right here, at this rate, usually tells me that I'm going to be using a proportion. And I can see that I'm comparing 2 different things here. I'm comparing the number of books to the number of boxes. And that seems to be a consistent thing, so that's proportional. So I'm just going to set up my boxes now. There are 4 boxes in a proportion. And I just want to get my numbers in the right place, which is why I start with words. All right, so there are 245 books in 7 boxes. I want to know how many books are in 19 boxes. So that's going to go on bottom with boxes, and then X is going to go on top. Now, I could rewrite this and do boxes over books, but that would flip the whole proportion. So just make sure you get your numbers with the right words. So then to solve a proportion, I cross multiply diagonally. So 245 times 19. 9 times 5 is 45. Carry your 4. 9 times 4 is 36, plus 4 is 40. Carry the 4 again. 9 times 2 is 18, plus 4 is 22. Let's write that second row with a 0. 1 times 5, 1 times 4, and 1 times 2. So add those up, and I get 5, 5, 6, and 4. Okay, and then after you multiply, you divide. I'm going to divide by 7, so I'm going to divide 7 to 4,655. 7 will go into 46 6 times, which would be 42. When I subtract, I get 4, bring down the 5. 7 will go into 45 6 times, which is 42 again. When I subtract, I get 3, bring down that last 5. 7 will go into 35 5 times, and then I'm done. So what does this number mean? It means that I can fit 665 books into 19 boxes. All right? And then 6 says there are 232 dogs in the 8 kennels at the doggy day spa. At this rate, how many dogs are in 5 kennels? So again, see this phrase, at this rate. That's my clue to use a proportion. I'm going to start with words. I'm comparing dogs and kennels. And I'm going to draw my boxes, 4 boxes. So here it tells me there are 232 dogs. So I'm going to put that with dogs, and I'm going to put 8 with the number of kennels. And I also have 5 kennels over here, so that's going to go down here with the kennels. And then what I don't know is the number of dogs, so that's my X or Y or whatever letter you want to use. To solve it, I'm going to multiply the numbers that are diagonal. So then 232 times 5. 2 times 5 is 10, carry your 1. 5 times 3 is 15, plus 1 is 16. 2 times 5 is 10, plus 1 is 11. But then I still need to divide by this last number here, the 8. So I'm going to divide 8 into 1,160. 8 will go into 11 once. I'm going to subtract and get 3, bring down the 6. 8 will go into 36 4 times. So that's 32, subtract and get a 4, bring down the last 0. 8 will go into 45 times. I can stop. So again, if I'm going to interpret my answer here, 145 is the number of dogs I can put into 5 kennels. That's a lot of dogs. Okay, and let's keep going. Number 7, a building is 240 meters tall. A scale model of the building uses a scale of 2 centimeters to 15 meters. How tall is the model? All right, so this is a type of scale factor, and it can be used, or you can use a proportion to solve this as well. So I'm going to be using the scale centimeters to meters, so I'm going to use those to set up my proportion, centimeters to meters. I'm going to draw my boxes. Okay, and then I can see there are 2 centimeters, that would be here, and 15 meters, the 15 would go here. And then additionally, I know that the building is 240 meters, so that's going to be on bottom, because that's where I put meters, and then what I don't know is how tall it is. Another way to describe this is you could say, all right, the scale, the model, okay, is in centimeters, and then you could say the actual size of the building is in meters. So you could even model the actual, I think it's easier to do centimeters to meters since they have different units. All right, and then to solve it, I'm going to cross multiply, so 240 times 2 would be 480, and then don't forget, you still have to divide 15 into 480. 15 will go into 48 3 times. Subtract 45, you're going to get 3, bring down your 0. 15 will go into 32 times. All right, and so again, I wanted to interpret what I just got here. So that was 32 centimeters for the model. The model is 32 centimeters tall. All right, looking at number 8, the triangles shown on the right are similar. What is the scale factor being used to transform the triangle on the right to the triangle on the left? So we need to be careful how we read this. So we're starting with this triangle on the right and going this direction. All right, so just pick a number from both of these. If I go from 15 to 5, all right, then I'm getting smaller. And remember, this is really dividing. I'm dividing by 3. I'm doing 15 divided by 3 in order to get to 5. But division isn't a factor, so I need to change it to division. So if I go ahead and say, all right, 15 over 1, and then keep, change, flip. So I'm keeping that part, changing to multiplying, and then flipping 3 over 1 to 1 over 3. Then what I actually am multiplying by is the 1/3. All right, so when I'm going from a bigger triangle to a smaller triangle, I'm actually multiplying by a fraction. So in this case, it was 1/3 because it's the same as dividing by 3. All right, for part B, it says, what's the scale factor being used to transform the triangle on the left to the triangle on the right? So this time I'm going this direction. So just to show that it doesn't matter what numbers you use, I'm going to use 3 and 9 this time. So since I'm going from 3 to 9 this time, I can see that I just need to multiply by 3 in order to get 9. So since I'm multiplying by 3, that is a factor, then 3 is just my scale factor. I don't have to change anything. Okay? On number 9, the triangle ABC and the triangle DEF are similar. What's the length of DF? So I can also use proportions since similar figures have proportional sides to find missing sides on similar figures. All right, so I could say I'm going to compare the big triangle to the small triangle and then set up boxes this way. So I'm going to pick a number on the big triangle, it's 24, and then I want to find the corresponding side on the little triangle would be 16. I'm going to go back to my big triangle, so 21 corresponds to the side X or DF, right, on this triangle. All right, so then I'm going to solve it. I'm going to multiply diagonally, 21 times 16. So that's 6 and 12. Start with a 0. 1 times 1 is 1. 1 times 2 is 2. Add those up. I get 6, 3, and 3. Then I still need to divide by 24. So 24 to 336. 24, I'll go into 33 once. When I subtract, I'm going to get 9 and bring down the 6. 24 will go into 96 4 times. Okay, so that means 14 is X. 14 is the length of DF. Okay, so I solved for X right here, which tells me that DF is 14 units long. Number 10, triangle ABC is similar to triangle ADE. If BC, that's right here, is 32 centimeters, what is the length of DE? So I'm looking for this length right here. Round your answer to the nearest tenth. All right, so sometimes it's harder to see the two triangles when it's drawn this way. So if it's helpful to you, you can pull these triangles apart and label them, and then it's easy to set up your proportion. So I can see right here that I have a small triangle kind of inside the bigger triangle. So I'm going to just draw them separately. So in the little triangle, this side is 12, and this side DE is what I'm looking for, and they've already labeled it X for me. All right, in the larger triangle, I can see that this side right here is 32, and this side on the bottom. Now this can be kind of tricky. So this side on the bottom is not just 6, it's all the way across. So I actually have to add these numbers together. So 12 plus 6 tells me the length from here A to B is actually 18. All right, and so now I'm going to set up my proportion. I can do the little triangle to the larger triangle to the big triangle. Set up your boxes. So in the little triangle, this bottom side is 12, and in the big triangle, it's 18. If I get back to little, this side is X, this side is 32, and then solving. I'm going to multiply diagonally, so 12 times 32 would be 4, 2, and I'm going to start with a 0. 3 times 2 is 6. 3 times 1 is 3. So that's 4, 8, and 3. And then I want to divide by 18. So 18 into 384. 18. I'll go into 38 2 times. And that's 36. When I subtract, I get 2. Bring down the 4. 18 I'll go into 24 one time. When I subtract 18, I'm going to get 6, so I need to add a decimal and a 0 and keep going. 18 I'll go into 63 times. 3 times 8 is 24, yeah, 54. When I subtract, I get 6 again. So I brought down another 0. I can see that this is going to repeat the 21.33. That 3 is repeating. It tells me to round to the nearest tenth, so I'm going to be rounding that number right there. I look at the number to the right of that, which is a 3, because it's going to keep going. It's always going to be 3. This number is not 5 or greater, so that just leaves the 3 alone. I don't need to round it up. So my final answer is 21.3, and this is in centimeters. 21.3 centimeters. All right, number 11. It says if triangle BAC is similar to triangle EDC, then angle B in triangle BAC is equal to which angle in triangle EDC? All right, so another property of similar figures is not just that their sides are proportional, but also that their corresponding angles are congruent, or the same measurement. So sometimes when you have triangles like set up this way, it's not always clear which angles correspond to each other. So one trick to use is that the order of the letters and tells you what angles are corresponding. So because B is first here, it corresponds to E. And since A is first here, it corresponds to D. And since C is last, it corresponds to C here. All right, so if I'm trying to find angle B, which angle corresponds to angle B, then if I just look at the order of the letters, since B is first here and E is first here, angle B corresponds to angle E. So my answer is angle E, and that's just the symbol for angle. And that's kind of maybe hard to see. You can sort of see here that D and A look like right angles. Anytime you have angles across from each other like that, those are going to be corresponding. So the only angles really left are E and D, or sorry, E and B. So these two angles correspond. So it's like they took the triangle and flipped it over and then flipped it over again. Okay, so just pay attention to the letters. That's helpful. All right, and then this video is getting kind of long, so I'm going to go ahead and stop it, and then I will do a part 2 to finish up the test review for chapter 4. Okay, thanks.